Hello and welcome to our next unit of the Geometry Interactive Notebook Flip Through. We are now on our Similarity unit. So this is the unit where I cover dilations and similar triangles. There's actually not a ton of topics on this one, it feels like. So let's just jump right into it. We start by talking about dilations, so we compare dilations to the congruence transformations covered in our transformations unit. We talk about the center of dilation, scale factors, the effects of dilation, how the sides of figures will be parallel in their image and pre-image, all that good stuff. We talk about the notation. And for the first day, we just do dilations that are centered at the origin specifically. The next day, we have a 2-page spread, and this is for dilations that are not centered at the origin. So I have them separated because I don't want to do too much in one day and have students get confused. So I teach them a counting method. I had to learn this for myself because when I was in school, we always used the origin as the center of dilation. This was completely new when they introduced Common Core. If I can find the video that helped me learn how to do this, I will link it below, but some glorious, wonderful math teacher put together a YouTube video where they showed an example of how to do this, and that was what I used as a reference. Next, we talk about similar polygons. I will find a link to this TPT product that I love to use. I can't even think of who it's by, but we do the notes. The notes are really short. We talk about how to determine if polygons are similar, and then I give them this sorting activity. So during regular teaching, it's a card sort. I think it goes up to it goes from letters A through O, maybe P even, probably P. And they have just pairs of polygons and they're determining if they're similar or not. So I really like to follow up this lesson, which is really short, with that card sort. During the pandemic, I turned it into a Google form, so it shows the card. I just took screenshots of every card, and then they have to choose if it's similar or not similar. I haven't decided this year if I want to go back to the card sort where it's hands-on, or if I want to keep it on Google. It's nice with Google Classrooms and it grades it, you know what I mean? And then students can go back and fix it, which is really easy because there's only 2 answers. But anyway, I'll link that below for you, but there's really nothing exciting going on in that lesson. Like, as far as the notes are concerned, it's 3 examples after we explain what similar polygons are. The next day we talk about the 3 ways to prove that triangles are similar. So we have a 3-flap foldable here for angle angle, side side side, and side angle side. So we explain the postulate or theorem, and then there's some examples for each. There's examples where they are similar and examples where they're not. And for the angle angle examples, we actually do like a mini proof there, so they get a little bit of an idea of what's coming the next day, which is similar triangle proofs. Before we get to that though, I do a sorting activity where students are sorting triangles into how they are similar. So we have a column for triangle similar by angle angle, a column for side side side, and then a column for side angle side. So I love the sorting activities because they allow for really great conversations. As students are doing these, I just always try to tell them, don't glue it down until I've checked it. So in the one day we are doing the sorting activity and these notes about similar triangles. The following day we go to the similar triangle proofs. This is a booklet foldable, so we have 5 proofs total, but we just go over those. They're the easiest proofs in my opinion because they're typically just you're saying that the triangles are similar by angle angle, which means they only need to find 2 pairs of angles. But I do include one example where they wanted students to prove something about the ratio, the proportion from the similar triangles. And then we move on to similar triangle applications. This is a longer lesson. It's 7 examples. It's not even like a lot of like notes, but it's just a lot of practice because there's a lot that goes on here. I have questions that are like mock Regents questions in particular. What happens is that on the exam for our state, there's a lot of variety of different ways of using the similar triangles. So I tried my best to hit all the different ways and all the different types of questions on this lesson. The following day we do indirect measurement. For indirect measurement, we have a couple of examples directly from the Regents exam. So I include those here. But I set up something in the back of the classroom. I have to think about what's the best way to explain this. I place a mirror on the floor, have one student stand a specified distance away from it, and then they're using indirect measurements and this example right here, well, this setup, I should say, to determine how far one partner needs to stand away from the mirror so that they could both see each other in the mirror by looking down at the floor. So that's just like a fun experiment to do, so that students are like actually up and moving and thinking and seeing how this works in real life. So indirect measurement is really fun. Now, it's January when we teach this unit. If it wasn't, I would love to go outside and do some kind of indirect measurement using shadows with something large. There is this enormous structure outside that I can see from my classroom. It was made of recycled telephone poles. So it's very tall and I don't even know how to describe it. The gym classes use it. I'm sorry, the PE classes use it. They don't even use it, to be honest. It's just kind of there now. But there's like a telephone pole that goes across, and it's like they walk across it. Then there's like a wobbly bridge that they walk across. So it's all suspended high up. There's harnesses, helmets, all that good stuff. It's like some kind of like outdoor adventure thing that they haven't done in a long, long time. But I always thought it'd be fun to go outside and measure that. But it's January and it's cold, so we don't. After indirect measurement, we have our final lesson of this unit. Like I said, it's pretty short. We typically fly through it, partly because it's the end of the semester and we want to try and get through it. But side splitter theorem is our last topic. So interestingly, I learned that it's not called the side splitter theorem everywhere. Certain states instead call it the triangle proportionality theorem. In fact, there's a few different triangle proportionality theorems or different proportionality theorems that other teachers teach in geometry. We don't, we just stick to this one with the side splitter for triangles. So I show students how to do that, and then we have 8 different examples. So a lot of examples on this. This is another one that they use on the Regents frequently as well. So we make sure that we hit all the different ways that they could ask about it. And that is everything for the 5th unit. Like I said, it's not such a big one. We kind of go through it pretty quickly, not that many topics. It's actually very repetitive. Once you start solving the proportions, like indirect measurement, side splitter theorem, it's still just solving proportions, just in a slightly different way. So that's everything for the unit. If you have any questions, please do not hesitate to ask, and definitely check out the description. I will share different links in there for some of the resources that I mentioned in this video. And as always, thanks for watching.